Okay, hi, hello everyone. I welcome you all to Unacademy. How are you all, my dear students? I hope that everyone is fine at their homes. And I am back bringing with me another amazing session for all my dear students. So I, Ritika, welcome you all here at Unacademy to ace your Term 2 exams with Unacademy Plus. So students, as you know that your term 2 exams are around the corner, so it is very important for all of us to be very serious now and start our preparations very seriously, right? Now Unacademy has brought with it amazing things, amazing plans so that you can take your preparations to the next level and you can score amazingly well in your term 2 examinations. Okay, so what are these plans and what has Unacademy in store for you? I'll be telling you soon. But before that, let's know a bit about me. So I am Ritika, a chemistry educator on Unacademy. I have completed my engineering in electronics and communication and also been awarded grade A by Cambridge English. So talking about our topic for today, what are we going to study? We are basically going to focus on the periodic table and the trends in the modern periodic table. So students, we are already doing this topic periodic table, and you know it becomes a very important topic for your term 2 examinations. Now we have already done the periodic table 1, okay, and today we are going to take the same chapter, same lesson forward, and we will be moving on towards the trends of the modern periodic table. Okay, so I hope you are with me. And before beginning, I would like to request you certain things. So first of all, kindly follow the Unacademy Champions page on Telegram. The link of this page is given to you in the description box. Now, why to follow this? Because you will be getting the links of all the YouTube classes, all the special classes, and of course the batches information in on this particular page. So this page will keep you updated regarding whatever is happening on Unacademy, so that you can take the advantage of all the classes that go on here. So I hope you got it and you will be following this page. And also, if you like this video, press on like button and please subscribe to the channel. Okay, you can press the bell icon so that you do not miss out any amazing updates of Unacademy. Okay, so kindly subscribe it and let us target 1000 subscribers for Unacademy. So for that, you will just need to share this link, share the page with your friends, okay, and they can also take advantages of the sessions that go on in here. Okay, now let us quickly start, and before starting we will be having a kind of quick revision of our previous topics. So we were studying about the periodic table, okay, and in our last class we saw that how did periodic table come up. There were various scientists who gave their ideas regarding periodic table. They tried to arrange the elements for a better and systematic study. Okay, so that was the reason why periodic table was made, but it was not one in a go kind of thing. There were many trial and error methods that happened before we had our main or modern periodic table. So this modern periodic table came after the trials of many scientists. For example, we had Daubonnier, we had Newlands, okay, we had Mendeleev's. So these all scientists, they gave their own theories, they tried what they could, and then we had our modern periodic table which we follow today. Okay, so what is or how to define a modern periodic table or periodic table? It is a kind of tabular arrangement of elements in groups, which are the vertical columns, and periods, which are the horizontal rows, which highlights the regular trends in the periodic or in the properties of elements. Okay, so a tabular arrangement, a table kind of arrangement of all the elements in groups and periods, which is known as a periodic table. And also this periodic table highlights or tells us about the trends that are seen in the periodic table. Now, this is our periodic table. Okay, our modern periodic table. Okay, so this is how it is arranged. If you can see here, alright, so these are the groups. These are alkali metals, these are alkaline earth metals, then we have semi-metals, we have basic metals, we have non-metals, we have halogens, we have gases, noble gases, inert gases. Okay, so these are the various things that we see in the periodic table. Okay, now salient features of the modern periodic table. So as you all know that our modern periodic table, it has got some of the features. Okay, so what are those features? First, it is having 18 vertical columns. So what are these columns known as? These columns are known as groups. So if someone asks you that what is the, just a minute, yeah, so how many groups do we have? We have 18 groups in our modern periodic table. Okay, now each vertical column, okay, it accommodates elements with same number of electron in the outermost shell. So I guess we already done this, that if I talk about a particular group, it will have the elements with same number of outermost shell electrons, right? Next, these vertical columns are known as groups, which are arranged from left to right in order of increasing atomic number. Just a minute. Yeah, okay. Then we have period. So period, they are 7 horizontal rows. Okay, these rows that you could see, they are known as period. So how many total number of period and how many total number of groups which are present in the modern periodic table? It is very important question. So there are 7 horizontal rows which makes 7 periods. Okay, now each period begins with an element having electron in its valence shell and ends with a completely filled outermost shell or valence shell. That means, see, for example, it will begin with one element in the one electron in the outermost shell, and it will move till we have a completely filled octet. Okay, so it will move towards, we have a kind of stable electronic configuration, and this stable electronic configuration is of none other but the inert gases. Okay, next, talking about the number of shells present in an atom determines the period. Okay, for example, if I say the period 3, so the elements of period 3, they will be having 3 shells. The elements of period 4, they will be having 4 shells. Okay, so this is how it goes on. Now talking about, okay, this was a basic let's say a recap of what we did in our last class. Now from now we will be going to focus on the various things which are periodicity and the periodic properties. Okay, so if I talk about periodicity, what do we mean by periodicity? It is the properties that appear at regular intervals. So we will be seeing a kind of regular repetition of various properties. Okay, so that is known as what? That is nothing but periodicity. Okay, so the properties that appear at regular intervals or in which there is a gradual variation. So what do we mean by this variation? Either it is increase or a decrease. Okay, so that these properties are defined as the periodic properties, and this phenomena, it is defined as periodicity of elements. Now, how to define periodicity? It is referring to all the properties which are appearing after a fixed interval, or they are showing a kind of gradual variation. That is, maybe let's say atomic size, it is increasing or it is decreasing, or it is first increasing then decreasing. So these will be a kind of gradual variation which will be shown, and this is defined as the periodicity. Next, talking about the periodic properties. So the properties of elements which are directly or indirectly related to their electronic configurations and show a regular gradation as we move across a period from left to right or down the group from top to bottom are called periodic properties. Now, let's focus on this topic, which is the periodic property. Okay, what do we mean by periodic properties? So these are those properties of elements which are related to their electronic configurations. Okay, so what is their atomic number, how are the atoms arranged in the element, okay, how are the electrons arranged. So it shows the property which is related to that particular electronic configuration. Now, how does these properties change? These properties change as we move across a period or down the group. So, for example, as we move down the group, the number of shells increases. Okay, so we will be seeing all the properties and what are the trends, how the change happen in moving from across the period or maybe down the group. Okay, so let us start with the periodic properties. Now, talking about the main periodic properties. So there are various periodic properties or which are related to the electronic configuration. First is atomic size, then we have metallic character, non-metallic character, ionization potential, electron affinity, electronegativity. So these are the 6 main periodic properties, and today we are basically going to focus on these 3, that is atomic size, which is the atomic radius, then the metallic character of the element and the non-metallic character of the element. So today we are basically going to focus on these 3 properties. Okay, now talking about atomic size or atomic radius. What do we mean by atomic size? What do we mean by atomic radius? So it is the distance between center of the nucleus of an atom and the outermost shell. Okay, so let's say this is our nucleus. Okay, and this is the outermost shell. Okay, so what will happen? The distance from here to here. Okay, so the distance from the center of the nucleus to the outermost shell, it will be what? It will be termed as atomic radius. Okay, so what is the definition? The distance between center of the nucleus of any atom to the outermost shell. Okay, so this particular distance, it will be what? It will be the atomic radius or atomic size. Atomic radius can also be defined as half of internuclear distance between combined atoms in a molecule. Now we just now saw the case in which there was only one atom. Now what do or how to know the radius when we are having the atoms in combination as in case of molecule? Okay, so let me show it to you. If I take the case of molecules, okay, so let's say there is one atom and there is so this is another atom. Okay, now if I take the case of nucleus, one nucleus will be here and the other nucleus will be here. Okay, so these are the 2 nucleus. Okay, now how to find the distance between these? If I take the case here, so this will be the distance. Okay, internuclear distance it is known as. Okay, so there are 2 atoms and we have taken the distance between nucleus of the first atom to the nucleus of the second atom, and this distance it is known as what? It is defined as internuclear distance. Okay, so these are 2 atoms. Okay, this being their nucleus, and the distance from first nucleus to the second nucleus, it is the internuclear distance. And the units that we use for presenting the atomic radius, first of all, the majority we use angstrom. Okay, and next is we use picometer. So angstrom, it is equal to 10 raised to power minus 10 meter. Okay, and it is symbolized as A, and there is a small circle over there, and picometer, it is 10 to power minus 12 meter. Okay, is equal to 1 picometer. So these are the common units that we use for representing the atomic radius. So I hope you understood the atomic radius, the definition. Okay, and there are two basic definitions. One is from the center of the nucleus to the outermost shell, and other, when we have the case of molecules, we take it from the radius from the nucleus of one atom to the nucleus of the other atom. Okay, so that becomes our atomic radius. Hope that is clear. Now, talking about what atomic size or atomic radius it depends on. So first it is number of shells, and next is nuclear charge. Okay. Now, I'll just give you a simple example. First, let's talk about number of shell. An increase in number of shell increases the size of an atom because the distance between outermost shell and the nucleus increases. Let's take a very simple example. I'm having one atom who has, let's say, 2 shells, and I'm having another atom who's having, let's say, 3 or maybe 4 shells. Now, if I talk about the distance from the nucleus to the outermost shell, what will be the distance here? It will be this, very small. And if I talk about distance here, it will be this. So you can see that as the number of shells are increasing, okay, so number of shells, as they are increasing, what is happening? The size of atom is increasing, right? Okay, and why is this happening? Because this distance between outermost shell and the nucleus, it is increasing subsequently. Okay, so first it is number of shells, and I hope it is clear. Next is the nuclear charge. So that is very important thing to note, and it will be of very great importance when we will be moving down the group and across a period, right? So it is the positive charge which is present in nucleus of the atom, which is equal to number of protons in the nucleus. Okay, so that makes the atomic number actually. So nuclear charge is the positive charge which is present in the nucleus of an atom, or which is equal to number of protons. Now, an increase in nuclear charge, which means increase in what? Atomic number. Now, that is important. Decreases the size of atom, because the electrons are then attracted towards the nucleus with a greater force, and therefore they bring the outermost shell closer to the nucleus. Now, if I tell you, that, okay, one atom is having only one shell, another atom is having, let's say, 3 shells. So a usual thinking would be, okay, the radius of this would be less than radius of this atom. Now there is a slight change in that, okay, because of the nuclear charge. So nuclear charge is equal to what? It is equal to number of protons, that is the atomic number. Now when the nuclear charge or the atomic number, it increase, with that the size of atom, it will not increase, but it will subsequently decrease. Why? Because the electrons which are present in the shells, they are attracted towards the nucleus with a greater force, and therefore they shrink the shell. Okay, therefore they bring the outermost shell closer to the nucleus. Now we'll be seeing how does this change happen. So trends in atomic size down a group. So in the group, the size of an atom increases as we go from top to bottom. This is because of addition of shells as we move from one period to the next. Now let's talk about period 1. Okay. So if I talk about period 1, group 1. Okay, first atom is hydrogen. Okay, so the size, it just has one shell. So this is the nucleus, and this will be the size. Okay, next if I take the case of lithium, the atomic number is 3 and it has got 2 shells. So one nucleus, this is the shell, and this becomes the another shell. Okay, so here we will be having 3 electrons. Okay, Next, if I take the case of sodium, what will happen? I will have one nucleus, one shell having 2 electrons. The atomic number of sodium is 11. So again, in the second shell, I'll be having obviously 8 electrons. And in the outermost shell, I will be having 1 electron. So the size of atom, okay, it is increasing. And what is the reason of this increment? That the shells are increasing. The shells are being added one by one. So as we are moving from top to down, okay, what is happening? The size of atom is increasing. That is very obvious. So the atomic size, it increases when we move down the group. Next is across a period. So I just now told you about atomic charge, right? So what happens is, as we move across a period, the atomic size, it decreases. Okay, now why is this happening? In a period, the size of an atom decreases from left to right. If I take the case of, let's say, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Now all of these are of the same period, right? Now if I take the case of lithium, the atomic number is 3, beryllium 4, boron 5, and similarly it will be increasing up till neon, which is 10. Okay, now what happens is, in the nucleus, okay, the electropositive charge which is present in the nucleus, what happens? It brings the electrons closer. It attracts the electrons. So because of this attraction, the outermost shell, it comes closer to the nucleus. Okay, so the more number of electrons which are present in the shell, okay, they will be attracted more. Okay, because this electropositive charge, it increases with the atomic number, right? And therefore they will be attracted towards the nucleus, thereby making the atom shrink or smaller in size. So what do we got to know from it? The size of an atom, it will be increasing from left to right because of the atomic charge or the atomic number, since it is increasing from left to right. Okay, so atomic number is nothing but the protons, the positive charge, and it tends to bring the outermost shell closer to the nucleus, thereby shrinking the size of the atom. Hope that is clear. Okay, now this is the basic diagram which I can tell that atomic radius, it is increasing from top to bottom, and as we are moving from left to right, the atomic size, it is decreasing. You can see in the case of lithium, beryllium, boron, carbon, etc. Right, now, so what we can say, if I take the case of third period, yeah, if I take the case of the third period, what will be the case? Sodium, okay, the atomic size, okay, this will be the largest, then magnesium, aluminium, silicon, phosphor, chlorine. Okay, now here this is the exception, okay, the exception of the noble gas. So the noble gases will be slightly bigger than halogens. Okay, now why is this thing? Like if I say the case here, okay, so chlorine and argon. So according to trend, we should say that the chlorine should be bit larger than argon, but it is not the case. Now why is this happening? Because noble gas, they have got the octet complete. They have got the maximum number of electrons in their outermost orbit, okay, and the repulsions are maximum. Okay, so this nuclear pull, the effect is reduced. Okay, so therefore the noble gas show an exception over here. Okay, next let's talk about the metallic character. So the elements which have the tendency of losing the valence electron to form a positive ion, they are considered as metals. Okay, now if I take the case of sodium, you all might be knowing that sodium readily gives its one electron, okay, to form what? The positive ion. which means the configuration here it's 281, which is the atomic number of sodium. Now the configuration is 2,8. Okay, similarly if I take the case of magnesium, okay, so magnesium, it is having configuration of 282. Okay, now it will readily give its 2 electrons, which makes it a positive ion. Okay, and the configuration will be 2,8. Okay, now the metallic size, it again depends on the size of the atom, that is atomic size, and next is the nuclear charge. Okay, now we will be seeing how is it related to these two things. Okay, first is the atomic size. Now, greater the atomic size, farther is the outermost orbit, and thus lesser is the nuclear pull exerted to it. Okay, if I say, or if I take an example of, let's say, 2 atoms, one is this and the other is, let's say I'm having many shells, right? So what will be the trend, or what will happen over here is the nucleus is very much closer to this shell, so the pull will be, the nuclear pull which is exerted on the electrons will be obviously higher. But if I go for the second one, what will happen, as the number of shells are increasing, the nuclear pull, it is less. Okay, now if the nuclear pull is less, what happens, the electron would be removed more easily from the outermost shell. And the more easily any atom loses the electrons, the more metallic character it possesses. So what do we get to know? As we move, or with the increase in atomic size, the outermost, just a minute. Yeah, okay, as we increase, just a minute. Okay, so as we increase the size of the atom, okay, as the number of shells are being increased, what happens, the nuclear pull, the value or the pull which is exerted, it becomes less. And as the pull is less, the electrons can be readily moved out. Okay, they can be removed more easily from the valence shell. And the more easily any atom loses the electrons, the more metallic character it possesses. So that is the atomic size relation. Next, talking about the nuclear charge. Now what happens with nuclear charge? Greater the nuclear charge, greater is the force exerted by nucleus on the electron of outermost orbit. So this makes it difficult to remove the electrons from the outermost orbit, and thus metallic character decreases. Okay, so if we have more nuclear charge, the nucleus will be exerting more force on the electrons of the orbits. Now the more force it holds to the electrons, it is difficult for us to take out the electron, and therefore the metallic character decreases. Now how does this trend happen over here? Let us see. Okay, now talking about the trends in metallic character. So down a group, if I talk about moving down a group, the atomic size, it will be increasing, right, due to nuclear charge. Okay, now okay, just a minute, I guess there's some network issue, I'm sorry for that. Okay, so as we are moving down the group, the atomic size is increasing subsequently. Okay, and the nuclear charge is also increasing. Since the number of electrons are increasing, the atomic number is increasing. Now this is very important. The effective atomic size is greater as compared to nuclear charge. Okay, so what happened? The tendency to lose electron, it will be increasing. Okay, and elements, they can lose electrons more easily. So that is why the metallic character, it will be increasing as we move down the group. Let me explain it to you again. So what happens as we are moving down the group? There are two things happening. Just a minute. Yeah, as we are moving down the group, what is happening? First is size is increasing. And second thing which is happening is the nuclear charge is increasing. Okay, so the two things are increasing. Now this particular effect, it is much more than nuclear charge. Okay, now the effect of atomic size, it becomes greater as compared to nuclear charge. Okay, now what will happen because of this? The electrons will be easily lost. We can easily, or the metals can easily give their electrons. Okay, they can easily lose their electrons. And as I already told you, the more easily any element loses the electrons, the more metallic character it possesses. So as we move down the group, what we will have, the metallic character, it will increase. So I can say metallic character, it will increase as we move from top to bottom. Next is across a period. Now on moving across a period, nuclear pull increases due to increase in atomic number, and therefore the atomic size is decreasing. So let me show it to you. Okay, for example, I am having one element here, second is here, third is here, and fourth is here. So this is the usual trend, right? The atomic size is decreasing. I'm sorry. Yeah. So the atomic size will be decreasing. Okay. Now why is this happening? It is happening because of the nuclear pull. Okay. Because there is a kind of increase in atomic number, that is the number of protons. Okay. Now it will be pulling the electrons with greater force. Okay, and the greater the force is, the more easily the atom can be shrinked, or the size can be reduced. Okay, so what is happening to atomic size? It is decreasing. So because of this atomic size decrement, what is happening? Electrons cannot be lost easily. So if I talk about the metallic character, it will be decreasing across a period when we move from left to right. So summarizing it, what will happen? As we move down the group, the metallic character will increase. As we move from left to right, what will happen? Metallic nature decreases. Okay, now what will happen here? Let's say I'm taking the case of some of the metals. Let's talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. Now what will happen over here? If you see the general trend, what is the case? The lithium and beryllium, they are metals, alkali metals and alkaline earth metals. Okay, the boron, it is what? Metalloid. And carbon to fluorine, they are the non-metals. So as you can see, we are moving from left to right. The property is changing. The metallic character is decreasing subsequently. So this will be the metal which very readily loses the electrons, then a bit less, then metalloid, and then non-metals. Okay, so that is the change. Okay, so this if I say what is the most metallic element in the second period, it will be lithium. Similarly, if I ask to you what is the most metallic element in the third period, it will be sodium, and so on. So this is how it goes. Okay. Next is the non-metallic character. So as in metallic character, we saw that the elements which readily give their electrons, okay, they possess metallic character. Now in the non-metallic character, what's the difference is the elements which gain the electrons to achieve a stable configuration of octet in their outermost shell or outermost orbit, they are the non-metals. So generally they do have 5, 6 or 7 electrons in their outermost orbits. Now why does this happen and what is the theory behind it? Let me explain it to you. So let's take a case of one metal or one element having Okay, so that is our that is the example of two of the elements. Okay, this is the nucleus. Now this particular element, it has got 2 electrons in the first shell, and it has got, let's say, 2 electrons in the second shell also. And here, if we take the case of this particular element B, it has got 2 electrons in their first shell, and it has got 6 electrons in the outermost shell. So the configuration is 2, 6, and here the configuration is 2, 2. Now this particular element A, what is easy for it? To give out the 2 electrons of the outermost shell, or to take 6 electrons in order to achieve an octet. So obviously it will be easy to give out 2 electrons. So what will happen? It will easily give 2 electrons to achieve electropositive character. Now here, if I take the case of B1, what will happen? It has got 6 electrons in the outermost shell. Now if I ask you that what is easy for this particular element, to give the 6 electron or to take 2 electron in order to achieve a stable configuration? So obviously it will take. Okay, so it has got 6 electrons, so it will be taking 2. If the case is 7 electrons, they can take 1. If the case is 5 electrons, they can take 3. So the non-metals, okay, they generally have 5, 6 or 7 electrons in their outermost orbit. And why are they told as non-metals? Because they are gaining the electrons to achieve a stable configuration, that is the stable configuration of octet, 8 electrons in their outermost orbit. Okay, so either 5, 6 or 7 electrons in their outermost orbit to achieve 3, 2 and 1 respectively to have an octet configuration. I hope you got it. Now talking about how is or what is it dependent on. The non-metallic character, it is dependent on, first of all, the atomic size. So the smaller the atomic size, greater will be the nuclear pull and the tendency to gain electrons. Okay, so therefore the element is more non-metallic in the nature. So the small the size of any element, the nuclear pull will be greater. Okay, and the tendency to gain electron, it will also be increasing accordingly. So element will be more non-metallic. Next is the nuclear charge. So the greater nuclear charge, greater is the tendency again to gain electrons, and hence more non-metallic is the element. Now how does this go on? Okay, so talking about the trends in non-metallic character down a group. So as we move down the group, what is happening? The atomic size is increasing. Why? Because the new shells are being added in successive periods. Okay, now nuclear charge is also increasing, but what is happening, as I told you, this atomic number effect, it overpowers the nuclear charge. So the effect of increasing atomic size will obviously be greater. Okay, so what will happen? The non-metallic character, it will decrease down the group. So as we move down the group, what will happen? Non-metallic character decreases. Now why does it decrease? Because the effect of the increasing atomic size will be greater, okay, as compared to the nuclear charge, okay, and therefore the metallic character will be increasing, and subsequently non-metallic character, it will be decreasing. Hope you got it. Next is across a period, that is when we move from left to right. Okay. Okay, so on moving across a period, the tendency to gain electron increases due to increase in nuclear pull and decrease in atomic size. Okay, so what happens? Non-metallic character, it increases across a period. So if I take the case of sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine, what will happen? These are the elements of the third period. So as I told you, the non-metallic character, it will increase across a period. So the character will be something like this, which makes the chlorine the most non-metallic and the sodium is least non-metallic, which is it is most metallic character. Okay, so therefore these are all metals. This is semi-metal or metalloid, and these are the non-metals. Okay, and if I talk about the group case, okay, so as we move down the group, let's take the case of group 14, that is the carbon family. Now, as I told you, the metallic character increases as we move from top to bottom, which means this will be most metallic and this will be least metallic, which means this will be a non-metal. Okay, so silicon and carbon, carbon is non-metal, and from silicon and germanium, they are the metalloids, and again this is metal. So what is happening? Metallic character, it is increasing, and non-metallic character is decreasing. So this is the trend that we will be seeing down the group. Okay, now I will be quickly having a revision session to make you understand once again what are the things we did. Okay, and then we will be moving on to some questions. So there were, first of all, 6 things that we it was dependent, the periodic properties. There were 6 properties and 3 will be covered in our next session, that is ionization potential, electron affinity and electronegativity. So today we basically covered about atomic size, metallic character and non-metallic character. Let us quickly revise it. Okay. So atomic size, what is first of all meant by atomic size? So it is, so it will be the distance between center of nucleus of an atom and the outermost shell. So in this case, the atomic size will be till here. Okay, now as I told you, the atomic size, it depends on how many shells the atom has and what is the nuclear charge. So number of shells, which means as the number of shells are increasing, the size of the atom will be increasing. Okay, and why is it happening? Because the distance between outermost shell and nucleus is increasing. Next is the nuclear charge. So nuclear charge is nothing but the positive charge which is present in nucleus of the atom, and that is equal to number of protons. Now what will happen as the nuclear charge increase? Okay, it will decrease the size of atom. Why? Because the electrons are attracted towards the nucleus with a greater force, and as the electrons are attracted, the size of the atom, it will shrink a bit. Okay, now talking about the trend, as we move from top to bottom, the size of atom, it will increase. Why? Because shells are increasing. Okay, so from top to bottom, the size of atom is increasing. And as we move across a period, that is from left to right, the size of atom, it is decreasing. Why? Because the atomic charge, it is increasing. Okay, and it is pulling the electrons, thereby decreasing the size. Okay, so this is the trend. Atomic radius is increasing, atomic radius is decreasing. Next is the metallic character. So metallic character is how easily an element can lose the electron, okay, to form a positive ion. Okay, and these are obviously considered as the metals. For example, sodium, it loses the electrons to form what? A positive ion and electron. Okay, so this also again depends on 2 things. First is the size and second one is the charge, nuclear charge. So let's see how is it dependent on them. Atomic size. So the greater the atomic size, what will happen? The outermost orbit will be far away from the nucleus, and since it will be far away, the pull that nucleus is exerting, it will be less. So what will happen? As the pull is less, the electron would be able to move easily. Correct? Okay, and as the electron is able to remove easily, it will be more metallic in character. Next is talking about the nuclear charge. So the greater the nuclear charge, the greater force will be exerted by nucleus on the electrons. Right? So if I'm holding anything very tightly, it will be very difficult for anyone to remove it. So same thing is happening with the nucleus and the electrons. Okay, the greater the nuclear charge is there, the more tightly it is holding the electrons. So it makes it difficult to remove the electrons from the outermost orbit, and metallic character decreases with increase in nuclear charge. So down the group, as we are moving down the group, what is happening? Atomic size is increasing and nuclear charge is also increasing. But effect of size, atomic size, it is much greater than nuclear charge. So the tendency or the capacity to lose electrons, it subsequently increases. Okay, and elements, they can lose the electrons more easily. So that means what happens? The metallic nature or the metallic character, it increases as we move from top to bottom. Okay, next talking about the metallic character across a period. So as we are moving across a period from left to right, what is happening? The nuclear pull is increasing, right, due to increase in atomic number. So atomic size is also decreasing, and elements are not able to lose their electrons easily. So therefore the metallic nature is decreasing across a period. Next is talking about non-metallic character. So what is non-metallic character? How easily an element can gain the electron to achieve a stable configuration or octet in their outermost shell. So all the non-metals, they generally have 5, 6 or 7 electrons in their outermost orbit to achieve 3, 2 or 1 electron respectively to have a stable configuration, right? Now, this thing again depends on atomic size and nuclear charge. So smaller the atomic size, greater the atomic pull, so it can gain electron much more easily. So element will be more non-metallic in character. And talking about nuclear charge, so greater the nuclear charge, greater is the tendency to gain electrons, and more non-metallic the element will be. So down the group, as we are moving from top to bottom, okay, the new shells are being added, the nuclear charge is increasing, atomic number is increasing, okay, atomic size is increasing. So the non-metallic character, it will decrease. And as we are moving from left to right, the tendency to gain electron, it is increasing, so more metallic. So the non-metallic character, it will be increasing across a period. So all in all, what are the things that we cover today? First of all, we talked about atomic size. Then we talked about metallic character. And then we talked about non-metallic character. Now, let's talk about the changes that we see down the group and across a period. So first thing, atomic size. Okay, so atomic size, what happens to atomic size? It increases as we move from top to bottom. Next, talking about metallic character. It will be also increasing. And third, talking about non-metallic character. It will be decreasing. Okay, so I hope that is much clear. Now talking about atomic size across a period. So what will happen here? First is atomic size. It will be decreasing. Next, metallic character. It will also be decreasing. And third, non-metallic character. It will be increasing. Okay, so these are the trends that we see for these particular 3 properties. Okay, now let's do some of the questions. The most electropositive halogen from all of them. So the most electropositive character. the most electropositive halogen. So as I told you, when we move from top to bottom, the metallic character increases. Okay, so from fluorine, chlorine, bromine and iodine would be correct answer. Next, the modern periodic law, it was given by Dalton, no; Mendeleev, no; Dobonier, no; Moseley. So Moseley was the scientist who gave the modern periodic law. Okay, so this will be our correct answer. And the next, while going up in the periodic table, the metallic quantity. Now you have to read the question properly here. While going up in the group, so as we move from down to top, what will happen? The metallic quality, it will decrease because as we are moving from top to bottom, the metallic character is increasing. So if we talk about opposite, it is obviously going to decrease. Okay, now talking about very important things, Unacademy subscription features. So students, Unacademy, as you all know, it's amazing platform to provide you learning from the comfort of your home. So if you subscribe for plus subscriptions, okay, or iconic subscriptions, what will happen? You can learn from the comfort of your home. You will be having unlimited access to all the courses. Okay, so whatever courses you opt for, you can have unlimited access. Next is you will be taught by top educators of India on one platform. Okay, apart from these things, there are some of the features which makes Unacademy all the more special. So first is we are going to have regular doubt clearing sessions. So obviously everyone has got doubts, right? So you will be having special sessions to clear all your doubts. And also you will be having answer writing sessions. Now what is answer writing sessions? This session will be giving you a brief about how to manage those 3 hours in your examination and how to write the answers in a way that covers everything. Okay. Next is exhaustive coverage of syllabus. So obviously your syllabus will be covered very properly in a better manner, and you will be having the mentorship and guidance of your teachers, of your tutors. Then talking about your study material. So all the study material that we will be teaching you, it will be given to you, of course, in the PDF format so that you can refer to it whenever or wherever you need to. Next is the practice test. So regular practice test will be happening. We will be having live test, combat test, polls, as you might be knowing. Okay, so these practice tests again are very important from your examination point of view, and for you also to know how much you are able to grasp certain things. Then we have live test series, okay, and also the batch courses. So students, you can use my code, which is RITIKACLIVE, and you can get daily practice session. You will be having mock test series, live quizzes, daily MCQ, and subjective test series. So these are some of the special features of Unacademy subscription. Now, how to subscribe for Plus, for ICSE board or for any board? What you can do is you can enter my Educator code, that is RITIKACLIV. Now this Educator code you can enter here. You can select the timing as per your requirements. It is 6 month, 9 month, 24 month, 48 month, whatever you need to or whatever you are comfortable with. Okay, so you can go for that. Now talking about a very important information pertaining to your term 2 examination. So as you all know that your exams are very much near, they are around the corner. Okay, so Unacademy is bringing with it the batch courses or the crash courses. Okay, so there is one course which is going to start from 17th of January 2022. Now this crash course, it will be available in both Hindi and English language. Okay, and the name of the batch or the name of the course is Mavericks. Here chemistry will be taken by Manisha ma'am, biology will be taken by Vani ma'am, and physics will be taken by Kalyan Krishna sir. Okay, Pragya, the math information will be given to you very soon, dear. Okay, so don't worry about it. As soon as we are clear with it, you will be getting the information. So students, if you subscribe for ICSE grade 9, you will be getting the grade 10 to 12 subscription absolutely free. So that is a very amazing thing again. Okay, so please make sure that you don't lose this opportunity. And as I told you, the batch, the classes delivery will be in both languages, Hindi and English. So Hindi, it will be taken by Shivam sir for maths, Vibha ma'am for physics, chemistry by Bhavana ma'am, and biology by Lakshya sir. So the batch name will be Udan, and again, if you subscribe for grade 9, you will be getting grade 10, 11 and 12 subscription absolutely free. Okay, yes Pragya, so if you subscribe for grade 9, you will be getting these 3 classes subscription free. So please make sure that you subscribe, and you can use my code, that is RITIKACLIVE. Now, Unacademy's free live classes, special classes. So students, Unacademy is providing free special classes in which you can have real-time interaction. We will be having chats, emojis, we will be having poll leaderboards. Okay, you can compete with your friends, you can see where do you stand. Okay, and also you can ask the question using the question tab. Now a very important information on how to watch this special class. So please download Unacademy Learner app. Please pay attention. Unacademy Learner app, if you download, you will open it and you will click on get started. Enter your mobile number here and you will be getting an OTP. So please enter it and then sign up using your email ID. Okay. So you can enter your name and whatever is asked. Then you will be selecting your goal that you are preparing for. So in your case, it will be class 6 to 12 and you will be selecting your classes or board. So you can select for ICSE or whatever your board is, CBSE or state board, whatever. Okay, and you will be selecting a language, Hindi, English, whatever. Okay, just select it. Now in the description of this video, you will be having a special class link. What you need to do is you just need to click on that link and there will be a pop-up which will ask notify me. So you will be notified just 10 minutes before the class begins. And how to enter that special class, you will be using my code. So what is my code? It is RITIKACLIV. So this is my code which you can enter and then you can unlock this special class for free of course. You can see it, you can take the advantage of these classes. Okay, so I hope you understood everything. If there is any confusion, you can connect on the chat box, and also you can ask to me on the Telegram channel. Okay, now let's recap about what we learned today. We learned about periodic table and some of the periodic properties. So we were having total 6 properties. We have completed 3 properties. We did atomic size, we did metallic character, we did non-metallic character. So we saw how are these properties related and what is the trend, what is the change that we see as we move across a period or we move down a group. Okay, so students, as you all know, the periodic table is a very important topic as talking about your term 2 examinations. Okay, now this becomes the second session of our periodic table. We will be meeting in the next session of periodic table, wherein we will be learning about the other 3 properties. Okay, so kindly make sure you share these links with all your friends. Okay, so that maximum students can take the advantage, and also don't forget to download the Unacademy app and try all of the features for very free. Okay, so you can get this app on Google Play Store or App Store. Okay, you can try all the features and you can take advantages of the amazing classes that go on here at Unacademy. Okay, so let us crack all our exams amazingly with Unacademy. Stay tuned, we will be meeting in the next class. Till then, take care, keep studying, and all the very best for your exams. Thank you everyone.